we've been talking a lot about two-dimensional squares, rectangles, circles. Well, now we're going to jump into the 3D realms here, talk about some three-dimensional figures. So let's just think, first of all, what kind of shapes we're talking about. I guess the most basic three-dimensional figure, we'll be talking about the box, three-dimensional rectangle, I guess, if you will. Yeah, these figures that we'll have now, and this is the attempt here to draw that, because, yeah, you've got 3 dimensions. You got length, width, and height to it there. So I'm going to talk about some different types of three-dimensional figures. One other, maybe you're thinking about, how about a cylinder? We'll deal some with those. Can shape, cones. We'll do a cone, a little bit on it. Let me also focus a little more here on a couple others. The pyramid. Another shape that, too, we'll talk about. On pyramids, you know, we usually think, when we're thinking pyramids, we're thinking the Great Pyramids, the pyramids over in Egypt there, which that is a good example of pyramids. But the thing about pyramids is the base can change up. Yeah, the shape of the pyramid. Of course, you always have the triangles for the sides, but yeah, in the Great Pyramids, in that example, we've got a square base, but you can also have really any polygon can be the base to a pyramid. We could just have there like a triangular base, where instead of, you know, having that square, just that base is just a triangle, and so you just have the 3 sides around there instead of the 4. Yeah. So on pyramids, you have it where you can change it up. Also, kind of on a related note, let me talk just briefly here about prisms. Prisms is the same sort of thing. Of course, on a prism, probably most of us would think the triangular prism, where the top and the bottom is a triangle. But just like on pyramids, that can change for prisms too. You can have any polygon be the top and bottom of a prism. Easy one, relatively easy one to draw, is like this shape here, where yeah, the kind of have to visualize a little bit, but yeah, the top and the bottom, trying to draw a trapezoid for the top and the bottom there. That is another possibility for a prism. You can have a hexagon be the top and the bottom of the prism. You can have a dodecagon be the top and bottom of the prism. Yeah, any polygon could be possibly your top and your bottom of your prism. So anyway, that's some of the shapes. We've got a few more, but those are some of the basic ones. Now, 2 things that we'll talk about when we measure, we want to measure on a box in cylinder and the 3-dimensional figures there. One thing you want to know, or can possibly calculate, is how much each one holds. What is the volume of these things? So volume is one aspect that we'll talk about for three-dimensional figures. And the other, capacity, let's just say how much it'll hold. And then we'll also talk about the surface area. And that is so called because it's just, as it sounds there, it's the total area of the surfaces, of all the surfaces. Yeah, we just take, like on the box, we take the front and the back, the area of that, the two sides, the area of that, add those all together, then the top and the bottom, add that to it. Just add the areas of all the surfaces together, called the surface area, for obviously good reason. All right, so now let me mention here too the units. Go into that for just a second. On volume, let's think about that for just a second. I'm trying to fill up, the box, the cylinder. I'm trying to figure out how much it'll hold. Well, I can't do that with, of course, just inches. Inches won't tell me, volume. Can't do it with a square inch. No, what I have to do on the units for volume is I have to take a 1 inch, say, inch is my unit here, 1 inch by 1 inch, and then I have to do the third dimension also 1 inch. So it's 1 inch long, 1 inch wide, 1 inch tall. That one over there. Unit. An inch by inch by inch. So I have to do an inch cubed for my units. If I'm doing inches anyway. Yeah, the units for volume are cubic units. I have to figure out how many of these cubic little cubes would fit into, say, the bigger box, or how many will fit into any shape, cylinder, cone, pyramid, whatever it is. I want to figure out how many of these little cubes I could fit into each one of those figures. So the units will be cubic units. Inches cubed is one, meters cubed, feet cubed, cubic yards, depends on size of your object, what you want to use for the units. Okay? Now, just for mentioning, go ahead and mention also to the surface area. Well, keyword there is area, and so the units for the surface area are just like area units that we've encountered before. What units did we use for area before? We used square units, so same thing for surface area. Surface area will be measured in square units. How many of the 1 by 1 squares will fit into various shapes. Okay? So that's intro into our three-dimensional figures. Those are the two things that, for a lot of these, we'll measure. We won't actually do surface area on some of these, but let's talk about some formulas. Three-dimensional volumes, surface area formulas. Okay, yeah. Let's just start here with the basic one, the box. Three things you do need to know when you talk about a box. Now, we will need to know the length, the width, and the height for a box. For volume, well, let me just draw an example here. Let's say we've got a 4 long box, 4 inches long box. All right, then it's going to be 2 units wide, 2 inches wide, and then 3 inches wide, high. Okay? All right, so there it is. 4 length, 2 width, and 3 is the height. All right, well, just like I did with the rectangle, let's grid the box off. All right, so there's those, and then I'm going to do some lines there for the height and then for the width. All right, then I'm going to come across here like so, and then I'll need to go across here too, don't I? Okay. All right. So doing that, what I've done is I've put the grid on there, and now these show how many of the cubic units, because each of those little blocks there is 1 by 1 by 1. That's 1 inch, that's 1 inch, and then it's wide 1 inch. So it's 1 inch long, 1 inch high, and 1 inch wide. So I'm showing the how many cubic inches I have there. If you think about it, I've got a front row and a back row. On the front row, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. And of course, on the back, I would have 12 of them. So that's 12 and 12, 24. So I've got 24 cubic inches, which, of course, is the volume. This box holds 24 of those cubic inches. Now, if you look at it, I've got the dimensions 4, 2, and 3. And is there any way to get 24 out of 4 and 2 and 3? Well, of course, multiply those 3 things together. 4 times 2 times 3, you got 24. Yeah, if you take the length times the width times the height, this gives you your volume of your cube. So it's pretty nice for volume of a box. Volume for a box is length times the width times the height. Okay? All right. Now, surface area. Surface area will denote with an S. So let's talk about surface area for this box. Like we said, surface area is just a measurement of the area of all surfaces. How many surfaces do I have for a box? Well, for a box, let's see, I've got, let me put some more lines in here. Let's do dotted for hidden ones. Okay. This. All right. So let's count up the surfaces I have. I've got a front and I've got the back. I've got the 2 sides, that's 4, and then the front and the top. I mean the top and the bottom. That's 6. 6 sides altogether. So I just come up with the area of each of those and add them together. Now, for the front, I've got the length and the height. So the area of that would be LH, right? Well, it just so happens I have an LH in the back too. So don't I have 2 LH? 2 LHs. For the sides, well, the sides are rectangles. They're WHs. So this area to the side is WH, and then I've got the left side, that would be WH. So I've got 2 WHs. And then that leaves the top and the bottom. Well, the top, that's L, and that's W. So I've got that's LW, and then I've got another one on the bottom, so I've got also 2 LWs. Surface area, yeah, surface area of a box is this formula right here. Okay? So it's basically you multiplying each dimension by the other dimension, multiplying it by 2. So up here, surface area, well, I take 2 times It'd be 4 times 3, so that'd be 2 times 12, and then I do 2 times the width and height, so that'd be 2 times 3 is 6, so I'd have 2 6s, and then 2 times the length and the width. The length is 4, the width is 2, so it'd be 2 times 8. 2 times 12 is 24, 2 times 6 is 12, 16, so that would be surface area of this one, 36, and 16 is 52. Square inches, yes, area is always inches squared. Square, whatever units it is. All right. So that's one example. Now, I do like to change it up a little bit. I like this problem for a box, and you can do this for a lot of these, but let me give you another example here. Let's say we had a box with no top, as shown here. I'll show you. So this box has no top on it. All right, so we've got, let's say it's 8 feet by 3 feet by 5 feet. But it doesn't have a box. I mean, it doesn't have a top. Okay? So the top's not there, just has the other. It has does have the bottom and the sides and all that, but okay. Volume-wise, that would be, well, it'd still be length times width times height. 8 times 3 times 5. No problem there. That would be 24 times 5. How much is that? Make sure I get it right here. All right, 24 times 5 is 120. Okay, and that would be cubic units. Yes, but let's talk the surface area. I like this problem because, yeah, it makes you think about the actual formula there. Now, in this case, since I'm missing the top, how many surfaces do I actually have? I usually have 6, but since I don't have a top, there's only 5. So you got to factor that in. What does that mean? Well, what that means is when I go to my formula, you know, it's usually 2 times the length times width, 2, so forth and so on. Well, let's think about it. Let's think about the front and the back. I've got 2, and the front and the back is 8 by 5s, right? This is 5. So that front would be 8 by 5, and then I've got 2 8 by 5s. Sides, well, I've got 2 of those, so I've got 2 3 by 5s. But when I go to top and bottom, there's no top. So there's no top, so I've got the bottom is 8 by 3, so I don't have the top, so I only have 1 of those. So yeah, what it means is instead of 2 of those, there's only 1 of those. Okay, so I like that problem just so you think about what you're actually doing there. All right, so that's 2 times, that'd be 40, so it'd be 80. 2 times 15, so that would be 30. And 1 times 24. So that winds up being altogether surface area 134. And units for surface area is the same as all area units, feet squared, to your square feet. All right.